Sir Kannan Gopalakrishnan. He was working as a senior architect at Engineering Design Research Centre, L&T Construction, India's largest construction company. He's also worked on projects ranging from institutional buildings to international airports, apartment complexes to aircraft hangars. He's also attended 3 international conferences and 2 national conferences, and has also presented technical papers at the Jawaharlal Nehru University, Delhi, and the MSRIT, Bangalore. He's also won the national championship at Archaman at the India's largest architecture quiz. Sir Kannan Gopalakrishnan currently runs a design firm, Habitat Design Studio, and he is also a visiting faculty at the renowned architecture schools in Tamil Nadu.
Welcome to UGC lecture series. Today we will be looking at lecture 3 of the subject Structure and Architecture. We will be covering the remaining parts of unit 1, which will be history of structural design in the pre-industrial era. In the previous episode, we just saw the history and importance of the arches. We saw different parts of an arch. We saw types of arches. We saw tall arches and their advantages over short arches. We saw vaulting, different types of vaulting. We saw how vaulting was an extension of making an arch, and we also saw domes. We saw domes as spiral multiplication of arches. We also saw buttresses and flying buttresses. We also saw important structural elements in ancient churches around the world. And today in this episode, we will be looking at tents and masted structures, bridges through history. We will be looking at different structural and architectural aspects of tents and masted structures, and also in bridges throughout history. Now let us get into the subject. The picture which you see on the screen is of a simple tent. Now let us try and define what a tent is. A tent is a shelter consisting of sheet of fabric or other material draped over or attached to a frame of poles or attached to supporting rope. While smaller tents may be freestanding or attached to the ground, large tents are usually anchored using guy ropes tied to stakes or tent pegs. A tent is very simple. Take 2 poles, attach them firmly to the ground. Once you have attached them firmly to the ground, tie a rope through both the poles. Once you have tied the rope through both the poles, you put a sheet of fabric or any other material on top of the guy rope, making it to a conical structure or a prism-like structure. Pull the fabric apart, pin it to the ground using pegs. You get a tent. If you could see the tent, there are essentially 2 very important parts. Obviously, you see the fabric, which is the blue color thing in the image. You can see the one on the top, and then the second part is the frame. Here, interestingly, the frame is made by a rigid pole, which you can see right in the middle of the picture. Any tent will have these 2 parts. This is a modern camping site where these are modern tents which have the extension of the same concepts of a fabric pulled over a particular pole or a structural frame. A fabric may be made of any material, including cotton, including nylon, including felt and polyester. If you could see, traditionally cotton tents are very used. In cotton tents, it is admirable that wet cotton is more waterproof than dry cotton. I am going to explain why. Take wet cotton for example. If you take a wet sheet of cotton material, the advantage of a wet cotton is there are these micro pores between cotton yarn. These pores are being covered by water droplets, which itself forms a waterproof layer. Traditionally, people also used to put paraffin and wax and other materials to make it a little more waterproof, and modern day materials also use silicone impregnation or polyurethane coating on top of this. When a canvas is being stitched, when 2 pieces of canvas is being stitched, there are these minute holes which comes out of the stitching, and these holes traditionally allow water to come inside, but modern day stitching methods have different sewing methodology which also has waterproof techniques. Next is the frame. The frame is the one that provides structural support. Some designs use rigid poles, typically made of metal or wood. Other designs use semi-rigid poles, typically made of fiberglass or sometimes of special metal alloys. Stakes or screws may be used to fasten the tent to the ground. These are the stakes. Sometimes the guy rope pull outward on the poles. These are the poles, pole number 1, and there is a pole number 2 right here, which we are not able to see because the tent fabric is covering that. There is a guy rope, which is this blue color rope, which is pulled outwards on these 2 poles. They are the ones that actually help shape the entire tent. Using these stakes, this guy rope is attached to the ground firmly, and now this tent fabric is put over the guy line and pinned again with stakes on all the corners. These little pegs or stakes can be made of metal, can be made of plastic, can be made of wood or any other suitable relevant material. This is a generic, simple way to make a tent. Now let us see how a tent works structurally. If we see tents, they are exact opposites of arches. If you see arches, we learnt in the previous episode that if you put a load on top of an arch, the primary load is taken by the keystone, and from the keystone, the weight of the arch, weight of the above material is transferred to on either sides through whizzers on the other stones. So from one stone to another, the load gets transferred from the top till the spandrel or till the bottom of the arch with pure compressive strength. There is no tension acting on an arch, and that is why arches were discovered as early, and it was one of the best forms of structural expression. Whereas a tent is, as I told you, is the exact opposite of what an arch is, because tent is a pure tension member, whereas arch is a pure compression member, except for the tent pole, which has a slight compression on it. All other parts of a tent are all completely tension members. See the guide wire, they are pulled apart and then they are pegged onto the ground. The tent fabric, they are put over the guy rope and they are pulled on either sides on all the 4 corners so that they can be pinned on the ground. So in that way, every part of a tent is a tension member. There is another concept called tensegrity, which we need to understand at this point of time. Tensegrity is an important concept which we should learn at this juncture. It was a concept which was found by architect Buckminster Fuller in the year 1960. This concept is a portmanteau word between tension and integrity. It is also called tensional integrity in very simpler terms. It is also called floating compression. It is a structural principle based on the use of isolated components in compression inside a net of continuous tension in such a way that the compressed members, usually struts or bars, do not touch each other, and the pre-stressed tension members, usually cables or tendons, delineate the system spatially. In tensegrity structures, there are usually more of these struts, and they are arranged in such a way that none of these struts actually touch each other. It is essential that we understand this because a very simple form of, very early, very rudimentary form of a tensegrity structure is what is expressed in the form of a tent, because there are 2 poles which are acting as struts which don't touch each other, and these struts are entangled in the guy ropes, the fabric, the other elements which make the tent. This is how the tent structure is formed, and tensegrity is actually an advanced principle which I am just giving you an insight about, because at this juncture tent is pretty much a very micro level tensegrity structure. These are the different types of tented structures. In this tent structure on the left, it is called a bell tent. It was predominantly used by the British during the Crimean War, during the early wars. And this tent on the right is a curtain tent. Curtain tent is a typical German way of building a tent. Here, this tent on the left is a Sahami tent or the Lavu tent, which is used by Nordic people. Nordic people are people who live in the Scandinavian region. they have access to wood, sticks and skin. So, this tent is made up of skin and wood. The one on the right is called a Finnish loo tent. A Finnish loo tent is not a complete cover. It covers only on one side of the tent, and in that side usually is the side in which the wind flow. A Finnish loo tent does not cover the entire perimeter of the area. It covers only one major side, usually the side where the wind blows from, because in Finland the winds are very harsh, and even if you build a fire, your fire is bound to get extinguished by the winds, by the cold winds that are blowing. So, you need a Finnish loo tent to keep the fire burning, and so that your fire does not get extinguished by the winds. So, a person can comfortably sit or sleep inside a Finnish loo tent with the fire burning right next to him, giving him a very comfortable feeling. A Finnish loo tent is very simple. It has only three parts. There is one pole which is kept at an angle, and the fabric is stretched onto either ends, and it is pinned using kegs on here and here. Alright, this tent on the left is a Tibetan nomadic tent, and this tent on the right is something which is very common to us. It is called a pandal, and we have seen pandals in India for a very long time. We use these pandals during festivals, during processions, during weddings, during a lot of ceremonies in India. All we need is a typical garden, and we can convert the entire garden into a wedding ceremony area. We can convert the garden into a fair, into an exhibition center, or into into a place where a religious function is being held. Such is the speciality of a tented structure. A tent can typically contain 1-2 people, or it could be as vast as it could contain thousands of people. Even a circus is traditionally being conducted on a tent. It's called a circus tent. That is the reason why it gets the name called circus tent. This tent here is a very interesting tent which is called the Sibley tent. It was designed by a person, Mr. Sibley. This is a very different tent from what we have seen earlier, because this tent usually is constructed over a tripod, and all the other tents require a guy rope, whereas this tent does not require a guy rope. It is put over 24 little pegs, and the fabric is stretched, and the entire thing is covered. And right in the middle of this tent, you could build a fire, you could put a tea kettle, or you could put a heating thing, and usually at the top of this tent is covered by another little structure which allows for the vent or the smoke from the fire to escape out. Let us look at larger tent like structures. Larger structures like this is a picture of Denver airport, is inspired from little tents, and the whole structure of the airport is comprised of many such tents. But this type of a large structure is not called a tent structure anymore, because tents are typically small, but these structures are now called as tensile structures. Another big example will be the O2 or the Millennium Dome, which is right here. This building was designed by Sir Richard Rogers. This is in London. This was constructed by tensile fabrics. The fabric is stretched over these members, and hence this entire big dome is formed. This is also a tensile fabric, tensile structure. We were talking about the principle of tensegrity, and this bridge, Kurilpa Bridge, is the largest tensegrity structure in the world. This is in Australia. Look at the way how the struts and how the tendons and how the tensile members are arranged here. Each member will never touch another member, and look at how the entire bridge is formed. Such an engineering marvel this is. This is one of the few places where true genius of architecture and true genius of a structural engineer meets. Let us move on to another interesting subject called the bridges. A bridge is a structure built to span physical obstacles without closing the way underneath, such as a body of water, a valley, or a road for the purpose of providing passage over the obstacle. There are many different designs that serve a particular purpose and apply to different situations. The picture on the right is the iron bridge. It is the first ever bridge made of iron, so hence the name Iron Bridge. If you had been wondering how early bridges were built, think about the smallest and the meanest little stream that you have crossed during a recent jungle trip. If you've been to a jungle, there is a tiny little stream coming, and the stream is about 2 feet wide, so you cannot, do a long jump and cross it. If it is more than 2 feet long, you cannot do a long jump and cross it with all the materials that you carry, at least not for little children and not for aged people. So how would you cross that little stream? It's simple. Take a log of wood from a nearby tree or from a nearby area, put it across the stream, walk over it. Look at how they've done here. There's a simple series of planks arranged in this fashion in such a way that they can span this entire area very easily. And this material is made of one single material, so that one single material structure is called a homogeneous structure, and hence the entire structural integrity is unquestionable. So for a reasonable weight like people, 1 or 2 people can easily cross the bridge with entire ease. Such is the simplicity of very, very basic rudimentary bridges. These bridges don't have a specific name, but they can be referred to as spank bridges when it comes to, if you want to name them, you can call them as spank bridges, but they don't have a very specific name as such. We will look at some of the other early bridges. This picture on the right is a living root bridge in Meghalaya. If you look at the evergreen forests in northeast India, in Meghalaya, in near Shillong area, there are these bridges that are made of roots and vines from the trees, and the trees are living and the roots are living, and the bridges that span smaller tiny rivers here, tiny streams, the bridges themselves are living. If you could see the entangled mess of all the root bridges that is present, people can walk very easily on top of these bridges. Now let us discuss different types of bridges, structural classification of different types of bridges. Based on structural classification, bridges may be of many types. We have always been looking at a lot of these types of bridges, and we can easily recognize these bridges once we see. The simplest of the type is a beam bridge. A beam bridge is nothing but what we saw in a rudimentary bridge here. This is also a beam bridge in a way, because there is a single platform of homogeneous material that is being kept over 2 supports. So this log of wood here acts like a simply supporting beam. So this is also a type of a beam bridge. So this is the beam bridge. There is a water body down, and these are the 2 ends which needs to be bridged, and this black thing here is the beam that we are talking about. Typical beam bridges could be like these. These are columns and beams that connect these columns. So hence, on top of these beams run your trains and railroads, your roads. These span the entire sea, oceans. There are bridges across oceans and rivers. This is another beam bridge which is built across a road. Look at the supports on the side and the beam. Another beam bridge. The next type of bridge is the truss bridge, which is a very, very common type of bridge, because a truss is a very easy element to build, especially with little steel members. All the members in a truss can be easily mass produced in an industry, and the connections are very, very simple and can be designed easily. And trusses can take huge amounts of load when it comes to integrity, when it comes to structural strength. So let us look at a few truss bridges. There are different types of truss bridges. There is a Warren truss, there is a Verendale truss, there are lots of types of truss bridges, and these are a few of them. The next type of bridge is called a cantilever bridge. A cantilever is, like we had earlier discussed in our previous episodes, is when an element is supported on one side and it is free on the other side. This type of bridge has 2 cantilevers, one on this side and another one on this side. Here it is supported on this side and it is free on the river side. It is supported on the pier and it is free on the middle. Examples of cantilever bridges are these. If you could see this particular bridge, this is the fourth bridge. This is a support. Here is the truss, and this part is actually cantilevered. This little part here is actually cantilevered from these bridges. So, hence this is called the cantilever bridge. If you see how it works, this bridge, this is how it works. These are the two pylons. This is a simple K truss. This middle portion here is a cantilever portion. The loading pattern is pretty simple here. All these green color members have compression acting on them. All these red color members have tension acting on them. Look at these green color members. These pylons are a purely compression member, and these bottom arms again have compression because there is load acting on either ends. So, these are on compression. These top arms are on tension because there is load acting on ends. In this cantilever, in all the cantilever, it is always such a way that there is tension in the bottom and compression on the top. So, this little part is cantilevered from these two portions. The next type of bridge is called the arch bridge, which is my personal favorite because arch bridges have been around the world since time immemorial, and ever since an arch was conceived, ever since an arch was invented, arch bridges has been the order of the day. It was simple, it was easy to build, it was easy to replicate, and it was the best used for democratic kind of a structure, because if you want to use a large number of people to build a bridge, you cannot have all engineers because engineers are very few people, and since you have a lot of laborers, it is easy for them to replicate because you just have to design one particular thing and then it can be replicated onto a number of things. And this is another reason why Romans, ancient Romans, built a lot of these arch bridges. They built bridges over water, they built aqueducts, they built bridges so that little chariots and little horses, that army can pass through rivers. They built aqueducts so that water can be transported from one part of the country to another. Let us look at a few examples of arch bridges. The next type of bridge is a tied arch bridge. It is also a type of an arch bridge, but from this arch, the actual bridge portion, the place where a person walks or a car moves, is actually tied to the arches like this. Let us look at examples here. This is a tied arch bridge. The next type of bridge is the suspension bridge. We did see a suspension bridge earlier in this episode. It was the Incan bridge. We saw how the ropes were suspended from a thicker rope, and that is how the whole bridge is getting supported. Let us look at suspension bridges. The most famous suspension bridge of all is the Golden Gate Bridge in San Francisco. These two things are called the pylons. From these pylons, there is this major rope which runs like this. From the major rope, there are these little ropes which actually keep the bridge up. Other examples of suspension bridges. Suspension bridges can be built to span very, very long distances. Look at the distance that this bridge is spanning. Next type of bridge is called the cable-stayed bridge. In this particular bridge, there is a tiny difference between a cable-stayed bridge and a suspension bridge. In a suspension bridge, there are two pylons, and then there is a major rope which is connected between these two structures like this. This is very similar to the guy rope which we saw in tented structures, but except for the fact that these two pylons are very far apart than a tented structure. And in a suspension bridge, you see this rope, but in a cable-stayed bridge, you don't see that rope. Instead, these pylons are comparatively larger than what we saw in suspension bridges, and there are cables from the top of these pylons which actually pull the bridge up and which actually makes the bridge stay in its place. So, it is the cable that stays the bridge, hence the name cable stayed bridge. You see examples of cable stayed bridges. A very famous bridge called Miller Viaduct, which is not in the pictures here, Miller Viaduct, designed by Norman Foster, was also a cable stayed bridge. Let us look at other types of bridges. A very interesting type of bridge is a movable bridge, because usually when a bridge is built, it is built on top of water, and in the water is also used as a means of transportation. Usually boats and ships move across waters and large rivers. So, these waterways also cannot be disturbed. So, when you put a bridge on top of a river, it kind of obstructs the movement of ships and bridges. How do you work this thing around? If you want to work this thing around, what we need to do is we need to build a bridge that can be editable, that can be movable from one place to another, or it can be changeable in such a manner that both roadways and the waterways can happen in the same bridge. The famous London Bridge is a movable bridge. If you look at this bridge, this is actually a tilt bridge, whereas this part here, if you see, this is the pedestrian path, and when a ship moves, this bridge looks like this. Otherwise, this entire thing rotates, and then in this portion comes and rests on top of this, so that this entire thing could be a pedestrian path across the river. This is another movable bridge. This is the famous rolling bridge designed by Thomas Heatherwick from Heatherwick Studios. This is built across a very small puddle of water here, and this bridge looks like this when it is used as a movement of people. Bridge looks like this when it is used for movement of small boats and barges. This is how it looks when it is retracting. The different types of movable bridges are the curl bridge, which we saw right now, when the bridge curls itself to form this kind of a structure. Next type is the drawbridge, which is something which we saw in the famous London Bridge. So, the bridge is pulled apart so that a boat can pass through. Next thing is a fold bridge. Bridge folds like the way it is shown in the picture. This is called a lift bridge, where the bridge is lifted so that a boat can pass through. Next is a roll bridge, whereas there is a weight acting on that side of the bridge. It acts like a little seesaw so that a boat can pass through. Then we have the submergible bridge, in which the whole bridge is submerged underwater so that a boat can pass through. Then the bridge comes up for roadways. Next is the swing bridge, which we saw earlier in the previous slide. So, when the boat wants to pass through, the bridge swings so that a boat can easily pass through. Next is a table bridge, where the bridge rises on tables to let the boat pass through. Then we have the thrust bridge, which retracts itself. Then we have the tilt bridge, which again is something which we saw on the previous slide. These are some of the future bridges that might be built in the world. I just put this slide so that we could show you the possibilities which we have in the future. Look at all the future possibilities that we have. It only gives us a firm belief that the future is definitely ours. So, from this lecture, we should be able to understand the history and importance of tented and masted construction. We were able to understand the different parts of a tent, how a tent works, tensile structures, tensegrity structures. We saw different types of bridges by structure. We saw the evolution of ancient bridges to modern ones, to the ultra modern, the futuristic ones. And with these learning outcomes, you should be able to answer a few questions here. Try answering these questions. Explain the structural working of a tent. What are the different types of tents? Explain them with relevant sketches and examples. How do tensile structures differ from tensegrity structures? Where are they used and how are they used? Explain bridge construction. Trace the importance of bridges through history and explain why it's relevant to study ancient bridges even today. Talk about the evolution of bridges with reference to structure types. with this, we also end the unit 1 of this particular subject. So, thank you.